Okay, now we're going to use all that work we just did to integrate. It helps so much. So the first one that we had was the integral of x cubed plus x over x minus 1 dx. But we realized we could divide this and make it easier. So we did that, and once we divided it, we got x plus 1. Oh wait, I think I divided it wrong the first time I did it. So what did I just do? Let me do it again. 1, 1, 0, 1, 0. 1, 1, 1, 1. Getting too nervous. 1, 1, 1, 1, 2, 2. Okay. So this ended up being x squared plus x plus 2 plus 2 over x minus 1 dx. So when we integrate this, this is really simple. This is power rule. This is going to be x cubed over 3 plus x squared over 2 plus 2x. And this is going to be the natural log. You could let u be x minus 1 and dx would be du. So it's really going to be 2 over u du or 2 natural log of x minus 1 plus a constant. So that's the first one. Here is the second one. We had the integral of x squared plus 2x minus 1 all over 2x cubed plus 3x squared minus 2x dx. And we discovered by rewriting it into partial fractions, it became 1/2 over x plus 1/5 over 2x minus 1 minus 1/10 over x plus 2. And so this simply integrates into 1/2 the natural log of x plus 1/5. Oh, okay, if we let u be 2x minus 1, du is 2 dx. And so we have to adjust by that constant. So we get 1/2 du. So this is going to be the integral, this is going to be 1/5. The integral 1/2 du gets us the dx, and then it's going to be 1 over u. So when we integrate that, that's going to be 1/5 times 1/2 or 1/10, the natural log of 2x minus 1, minus 1/10 the natural log of x plus 2 plus a constant. And so that's how we can integrate that so easily after we get that one. All right, number 3 was this one. We have the integral of 2x squared minus x plus 4 all over x cubed plus 4x. And so we rewrote that into the integral of 1 over x plus x minus 1 over x squared plus 4 dx. Okay, so how will we handle this one? 1 over x integrates into the natural log of x. That's no problem, right? That is what that is. But this right here, what will that be? What I'm going to do is split this into 2 fractions. So this becomes 1 over x plus x over x squared plus 4 minus 1 over x squared plus 4 dx. And when we integrate 1 over x, we get the natural log of x. Okay. This is a u substitution. So I can let u equal to x squared plus 4. Du is 2x dx. 1/2 du is x dx. So what do I get here? This is going to be 1/2. 1/2 du gives me the x dx. So it's going to be 1 over u. So this ends up being plus 1/2 the natural log of u, which is the natural log of x squared plus 4. This is always positive, so I didn't need absolute values. minus this. Okay, 1 over x squared plus 4. This is tangent inverse. So instead of with that a, right, the integral of 1 over x squared plus u squared is, or a squared I should say, is tangent inverse of x over a times 1 over a. That's one of our tangent ones. Let me just make sure I wrote that down right. Did I write it down somewhere? Yeah, it's going to be 1/2 tangent inverse of x over 2. So it's minus 1 over a, 1/2, tangent inverse of x over 2, plus a constant. Now, you could also use a u substitution, or divide out 4, factor out of 4 to get this right here, if you wanted to see how the a's are working. But this is also on our integration sheet of things we should know. All right, number 4, the last one, goes like this. If you have the integral of all of this stuff, right, we had 1 minus x plus 2x squared minus x cubed all over x times x squared plus 1 squared dx. We were able to rewrite this into the partial fraction decomposition of 1 over x minus x over x squared plus 1 plus x over x squared plus 1 squared dx. Let me make sure I am agreeing with that. What do we get? We rewrote it as 1 over x. Am I agreeing with that? Minus x minus 1. Let me see. Hang on. Let me make sure. What do we get? See, I'm missing something. This is supposed to be minus 1, right? I think that's supposed to be minus 1. 1 over x, this. Okay, that's good. So we rewrote it into a partial fraction decomposition. I'm going to split up these little fractions. So this is going to be 1 over x dx minus x over x squared plus 1 dx minus 1 over x squared plus 1 dx plus x over x squared plus 1 squared dx. So plus this integral. So I just split them up into different little integrals. It makes it much easier. This one is natural log of x. Now here, I'll use a u substitution. I'm going to let u equal x squared plus 1. du is 2x dx. 1/2 du is x dx. So this ends up being minus 1/2 du is my x dx, 1 over u. So this ends up being minus 1/2 the natural log of u, which is x squared plus 1. Okay, so that's these two so far. Right here, this I recognize as tangent inverse. So this is minus tangent inverse of x, is what that one is. And right here, I can use the same u substitution. So if I let u be x squared plus 1, okay, du is 2x, so 1/2 dx gives me x dx. So this is plus, by writing down 1/2 du, I get the x dx. And so this is 1 over u squared. So this is 1/2 u to the negative 2 du. So that's going to be u to the negative 1 divided by negative 1, or minus 1/2 u to the negative 1. U to the negative 1. But u is really x squared plus 1. So this is what we get when we integrate that. So you can see how by writing it in partial fractions, it makes it really simple to integrate. All right, that's it.